Hello and welcome to a new series I'd like to call Fac and Fab. Fun and kind of not fun facts about physics, because I study physics. And over the time I've learned a lot of fun things about physics, and also a lot of not fun things about physics. And being the person I am incapable of keeping anything to myself, so I am inviting you to join me on the first ever Fac and Fab. When considering a ball from the same height, regardless of whether you shoot it horizontally or drop it straight down, it should land on the ground at about the same time. This is because just like two people who have moved on from a breakup, the horizontal and vertical components of motion are independent of each other. They do not rely on each other. They do not need each other. Sorry about that. As I was saying, even though ball 1 has velocity in both the x and y direction, and ball 2 only has velocity in the y direction, because these velocities in the y direction are the same, the ball will travel down the same distance in the same time. So next time you're being launched out of a cannon, just remember, this will take the same amount of time as it would being dropped from a helicopter. And that might not help, but it is true. Many people are familiar with the concept of velocity, how far you're going over how long it takes you. For example, in a car, kilometers per hour, or miles per hour, because I'm trying to make friends here. We can refer to this as the change in position over the change in time, or the time derivative of position. Many people are also familiar with acceleration, which is how the velocity is changing over time. A car with a faster acceleration will reach top speeds in a shorter amount of time. This is position over time, or the second time derivative of position. Well, we can keep taking time derivatives of position. The third time derivative of position is called jerk, like the chicken. Or like my ex, who I'm completely not. Sorry about that. The fun fact here comes from the fact that the fourth, fifth, and sixth time derivatives of position are called snap, crackle, and pop, respectively, named after the Kellogg's mascots. Planets don't actually orbit the sun in circles. Electrons don't orbit atoms at all. Planets actually orbit in ellipses, or ovals. The shape of a planet's orbit can be described by its eccentricity. You know how when you were a kid and people used to call you eccentric? They weren't calling you weird, they were just calling you elliptical. Or ovular. Or I don't know. Anyway, an eccentricity of 0 does correspond to a perfectly circular orbit, but the more it increases, the less circular it becomes. Just like the more eccentric you are, the less normal you are. Most of the planets in our solar system, however, have very low eccentricities, almost 0. Therefore, these orbits are basically circular, just not quite. The one with the highest eccentricity value currently in our solar system is Mercury. So that's you. You're Mercury. You're, like, not extremely eccentric, but significantly more than everyone else around you. So, good job. Rather than thinking of electrons as orbiting atoms as discrete particles, it's better to think of the charge as being spread around the nucleus in a cloud, rather than one singular large drop of water hurtling towards the Earth. These shapes are called orbitals, and they are determined by the probability of finding an electron in the region. The energy level of the electron also impacts the shape of these orbitals. So, we got little sphere, big sphere, dumbbell, little sphere, bigger sphere, weird kind of lizard eye, crucifix. I don't think these are the scientific names for these orbitals, so don't quote me on it. Yeah. Most people are probably familiar with the term calories when it comes to eating food, but do you know what calories actually are? Calories are the empirical unit of energy. 1 calorie with a small c is the amount of energy it takes to raise 1 milliliter of water by 1 degree Celsius, which is kind of odd that it's an empirical unit of measurement when it's based on the metrics. The calories we see in food, however, are kilocalories or big C calories. This is 1,000 smaller calories, or the amount of energy needed to raise 1 liter of water by 1 degree Celsius. Because calories are just a unit of energy, they don't have to be restricted to only food. A gallon of gasoline contains 31,000 calories. Now, this does not mean you should drink gasoline. Please don't let the takeaway from this video be please do not. Anyway, by rearranging some of the math, we can determine that it'll take approximately 2.6 Big Macs worth of calories to drive a Dodge Grand Caravan 1 mile. If the Dodge Grand Caravan ran on Big Macs. Which it does not, but it's the thought that counts. Sound is just wiggly air. Many people have probably heard the term sound waves before, but how does sound travel in waves? I thought it traveled in sound. In the most basic sense, sound is just vibration, and the way it propagates is by having particles bang into each other, in a sense. Like a bunch of people who are line dancing. Who are all very bad at line dancing. Sound traveling through air can be thought of as repeated regions of more compressed and less compressed air. So the next time you're listening to music and poorly line dancing, just remember, the air around you is poorly line dancing as well. So even though you may not be good at line dancing, at least you're not alone. Alright, thank you. That concludes this episode of Fack and Fap. Let me know if this was interesting or not interesting as well. That is, of course, a goal of this series too. And let me know if you want to see more. Thank you. That has been all. Have a nice day.